Okay, the next kind of section we're going to talk about is an ellipse. Okay, so an ellipse is a regular oval shape. So it's kind of like a circle, but stretched. Okay, and it's where all the set of points whose distances to two fixed points add to the same constant. And I know that just sounds super confusing, but essentially these two fixed points that are creating this same distance are called our focus points, and the plural form of those are foci. So our focus points we could see are right here and right here. Okay, sometimes our focus points will be on the x-axis, sometimes they will be on the y-axis. It just depends on where this thing called the major axis is. Okay, and we call it the major axis. We could see right here in this picture is always just the longest axis, so the longest distance between two of my four vertices. Okay, so again, the foci are always on the major axes, and the center of the ellipse is always the halfway point between the foci. I know this is a lot of new terminology, but once we get into the graphing, I'm more concerned on, can you find the four vertices, can you find the center, can you find the foci, and graph this ellipses. Okay, so the standard form of an ellipse is kind of like a circle. So we're still subtracting h and we're still subtracting k. Okay, so it's x minus h squared all over a squared plus, so it's always plus. Remember that, it's always plus. And then y minus k squared over b squared equal to 1. Okay, keep in mind, when we have an ellipse, a will always be bigger than b. So when you are given numbers in your denominators, the bigger number is always going to be representing our a, and still we have our h and we have our k representing our center, which I have labeled for you right here. Okay, so a, since it's bigger than b, is always going to determine how far from the center we're traveling on the major axes. And now, like I said, the major axes might either be on the x-axis or it could be on the y-axis. So it really all depends on where your a is located. So if your bigger number is located under x, so let's say this case, that's your a, and you're going to be traveling along the x-axis. If your bigger number was under the y variable, well then you're going to be traveling along your y-axis, and that's going to be your major axes. But in this case, in the standard form right here, the major axis is going to be underneath the x because a is underneath the x. So that's always going to determine that for you. And so b determines how far we travel along the minor axes, so the smaller axis. Okay, and c represents the distance of our foci from the center. Okay, and to find c, we use this formula, c squared equals a squared minus b squared. So this kind of probably reminds you of the Pythagorean theorem, but the reason why the variables are switched around a little bit is because a is actually bigger than both b and c. Okay? All right, so let's get into the actual examples. So I want you to identify the center, the major axes, the vertices. So the vertices are always on the major axes. I'm going to write that. And the co-vertices is on your minor. So your A is going to determine where your vertices are. Your B value is going to determine where the co-vertices are. And then we're going to find the foci, and we're going to sketch the graph of the ellipse. Okay, so it doesn't matter really what order you do some of these, but the first thing I always want you to do is to find your center. Okay, so I don't see anything being subtracted from x or y, so that's telling me that the center of this ellipse is at 0, 0. Okay, I'm looking at now my two denominators, and 16 is the bigger one. So that means that 16 is my A, and this is my B. So it's telling me that I'm going to be creating a major axis along the x-axis because A, or the bigger number, is underneath the x-axis. Now that's not that important to remember that that's going to be the major axes, but it is important to remember which one's going to be A and which one's going to be B. So A is always the bigger number. Okay, well this is actually saying this is A squared and this is B squared. So I need to figure out A. So I'm going to take the square root of 16, so A is 4. And I need to figure out B. And I'm going to take the square root of 9, and that's going to tell me that B is equal to 3. Okay, so I am actually going to be able to graph with this information, and I'm going to do that before I find the rest of the information I was asking you to find. So I'm going to plot my center at 0, 0. And this right here, A equals 4, is telling me that I need to travel along the x-axis 4 spots in both directions. Okay, so on the x-axis, right, the horizontal, I'm going to go 4 spots to the left, 1, 2, 3, 4, and I'm going to plot that point. And I'm going to do it in the next direction, so I'm going to go right, 1, 2, 3, 4. Okay, so I just created a major vertex. Okay, I just created a major vertex. Now I'm going to see, well, which way do I need to travel along the y-axis? Okay, because this number is underneath the y, that's where I'm going to travel on the y-axis. So my B is 3. Let me do this one in a different color. So that means I need to go up 3, 1, 2, 3. There's 1 point, and I'm going to go down 3, 1, 2, 3. So there's my other point. Okay, so now I could actually connect these points right here. I'm sorry, that's creating a circle. I do not want that. Okay, and I kind of have this awkward looking football, but this is my ellipse. Okay, so because this distance is smaller than this distance right here, this is my minor axis. Again, you don't technically need to know this. I more want you to know which one's your major axis, and that's always just the longer one. Okay, and then the vertices that are on the smaller axis, we just call these the co-vertices. Okay, and if I ask you to identify them, I really just want the point. So this is located at my co-vertice. Let me write it over here. Well, let me label it first, and then we'll do that. So this co-vertice is labeled at 0, -2. This one is at 0, 2. My major vertices are at -4, 0, and 4, 0. So let's write this over here. I know my center's at 0, 0. My vertices are at 4, 0, and -4, 0. My co-vertices, so they're on the smaller axes, is 0, 2, and 0, -2. And now I need to find the foci. Okay, so the center is the midpoint between the two foci. So I'm going to use the formula c squared equals a squared minus b squared. Now this is why it's important to know that a is the bigger number, because you need to plug it in properly to this formula. So c squared is equal to, well, we know a is 4, and we know b is 3. So c squared equals 16 minus 9. So c squared is equal to 7. Okay, and then I'm going to solve by taking the square root. So c equals the square root of 7. So you are going to use this to count from the center on the major axes. Okay, so that means you need to approximate the square root of 7. We know it's between the square root of 4 and the square root of 9, so it's 2 point something. So we know it's between 2 and 3. So I'm going to count a little over 2. 1, 2. And this is going to be my foci. I'm going to label that with an F, and I'm going to do it in the same, I'm going to count the same amount, but in the other direction. So 1, 2, a little over 2. So here's my foci right here. Now remember, this is the longer axes. This is the major axes. That's where you count your foci. Okay, your foci are always on the longer axes, so you have to be able just to identify the major axis. Okay, and there's your ellipse. So let's do this again. So in number 2, my center is at 0, 0, because nothing is being subtracted from x or y. Okay, so let me plot that. And I need to identify my a and b. Well, here's the bigger out of the two denominators, so that's going to give me my a, but I have to take the square root, so a is equal to 6. And then this is going to give me my b, so I'm going to take the square root. B is equal to 3. So from the center, I'm going to count, since the a is under the x, I'm going to count 6 along the x-axis left and right. So I'm going to go 1, 2, 3, 4, 5, 6. There's one vertex. And then I'm going to go the other way. 1, 2, 3, 4, 5, 6. There's my other vertex. And since this is the longer one of the two, this is my major axis. Major axis, okay, because it's the longer one. 6 is much bigger than 3. Okay, so then since b is underneath the y, the 3 is underneath the y, I'm going to count along the y-axis up 3 and down 3. So 1, 2, 3. There's my co-vertice because it's on the smaller axis. 1, 2, 3. Here's another co-vertice. You don't necessarily need to write that. And then we're going to connect our points. Sometimes if you hold it down in Notability, it'll make the ellipses for you. But if you saw in my other example, sometimes it'll make a circle, so just be careful. And then we are going to graph the foci. Okay, so we're going to use the formula c squared equals a squared minus b squared. Well, we have 6 squared minus 3 squared. So c squared equals 36 minus 9. And so c squared equals 27. So c equals the square root of 27, that's 3 root 3. But since we have to kind of count from the center, we're going to approximate. So you could literally just put in your calculator the square root of 27, and it's 5 point something. So it's between 5 and 6. So again, the foci go on the major axis, so the longer axis, so the longer distance between two of your vertices, that's your major axes. So I'm going to be counting on the x-axis, so I have to count a little over 5. So 1, 2, 3, 4, 5. So somewhere over here is a focus point, and then 1, 2, 3, 4, 5, and then a little over here is another focus point. Okay. And if you wanted to actually label your points, let's label let's label our vertices first. So this is at, let me do it in the same color. This one is located at 6, 0. This one is at negative 6, 0. My co-vertices are at negative 2, 0 and 2, 0. Okay, so let me label these over here so we can be neat with our work. So co-vertice, we have 0, 2. Oh my gosh, I labeled those wrong. Sorry, guys. 0, negative 2. I flip-flop these. And 0, 2. And 0, negative 2. We have major vertices at 6, 0 and negative 6, 0. And then if we want to label the foci, I'm just adding spots from the center. So notice that all that's moving is the x value, not the y. So I know the y is still going to be 0 on the foci. All you're doing is taking away or adding to the x value. And we did that by adding 3 root 3 and subtracting 3 root 3. So my original point, or my center was at 0, 0. So I'm taking 3 root 3 away from 0, and I'm adding 3 root 3 to 0. So that's going to give me my 2 foci, but we could rewrite that as negative 3 root 3, 0, and 3 root 3, 0. Okay? Or you could just know, you could recognize that this point is, well, this is 3 root 3 on the x-axis, negative 3 root 3 on the x-axis, and 3 root 3 on the x-axis. Okay, let me go back to this problem so we could label our focal point here. So now if I want the foci for this one, my center again was at 0, 0. So we start at 0, and our major axis is along the x-axis, so you're just shifting along the x. So all that's changing is the x, not the y. And we know how much we moved. We moved root 7, so I moved left amount of root 7, and then I moved right root 7 along the x-axis. So if we want to rewrite these, it's negative root 7, 0, and positive root 7, 0. Now, am I going to be a big stickler on you labeling your foci? No. But next year, when you guys get into conic sections, you will have to be able to label these. So it's just good practice to try to identify the actual location of your foci. But you do definitely need to at least graph them if you can't label where they're located. Okay. So in number 3, this is a little bit different because now we have a different center other than 0, 0. So I'm looking at these two numbers. So in this case, my center is located at 2, negative 3. So it's still opposite of what you would think. So if it's inside of the parentheses being squared, regardless if it's an x or a y, okay, it's always going to be opposite of the number that you think. So it's going to be 2 and negative 3. Okay, here is the bigger of the two denominators. So I know that's going to be a. And I'm going to take the square root of a squared. Right, this is a squared, this is b squared. So a is going to equal 6. And b is going to equal 4. Okay, so now let's use that information to graph this. So my center, we said, was at 2, negative 3. So positive 2, down 3. Okay, and then I'm going to count my major axes. So since A is underneath X, that means I have to move 6 right and left on the X-axis or along the X-axis. So 1, 2, 3, 4, 5, 6. And I'm going to go left, 1, 2, 3, 4, 5, 6. Okay, so this point, I'm going to label it right away, is at negative 5, negative 2. This point is at, 3, 4, 5, 6, 7, 8, 8, negative 2. Okay. Oh, I'm sorry, this is at 4. See, I hate that these numbers are offset. I'm sorry about that. So this is at negative 4. Okay. And then I'm going to count 4 along the y. Y means up and down, right? The y-axis is up and down, so I got to count 4 up and down. So 1, 2, 3, 4. And this is at 2, 1. And then I'm going to count down 1, 2, 3, 4. And this is at 2, -7. And then I'm going to connect these 4 points. Okay, again, the dark purple is on the longer axis, so this is a vertex and this is a vertex, and the green are on a shorter axis, so we call these co-vertices. So let's label these over here. So we have our center, our major vertices we labeled as -4, -2, and 8, -2. My co-vertices, 2, 1, and 2, -7. 2, -7. Okay, now let's find the foci. Okay, so we're going to use c squared equals a squared minus b squared. So we could see that this is a squared, this is b squared, so you could just plug those in as is, or you could plug in the 6 and the 4. Either way works. So c squared equals 36 minus 16. Okay, so c squared equals 20. So c equals 2 root 5. Or we could say 4 point something between 4 and 5. So let's graph that. So again, your foci is on the major axis, so the longer axis. So that means I got to count left and right. So I'm going to count 1, 2, 3, 4. Somewhere in between here, there's a focal point. 1, 2, 3, 4. A little over 4. There's another focal point. So since we're moving along left and right, that means the x is changing. So from the center, I'm going to start with the original center, and that's 2, -3. However, the x is changing. I'm actually going to make this plus minus because we took the square root. Let me go back and fix those. Plus minus. Plus minus. Okay. So we're adding and we're taking away 2 root 5. So plus minus 2 root 5. If you want to write those as two separate points, we could say 2 plus 2 root 5. -3 is one of my focal points. And 2 minus 2 root 5. -3 is my second focal point. Again, I'm not super concerned about you actually finding the coordinates of the focal points, but it is good practice for next year. Okay, you at least need to be able to graph them. Okay, and then finally, number 4. Again, I'm looking at what's inside of the parentheses of my x and my y to find my center. So my center is at -1, 2, again, opposite of what you would think. And notice that the bigger number is now underneath the y. So that's my a squared, and this is my b squared. So now a and b are switched. So that means our ellipse is going to be graphed looking kind of opposite of what we had. It's going to be laying on its other side. So I know that a is equal to 6. Let's do b in purple. And b is equal to 5. Okay, so let me plot my center first. So my center is at -1, +2. So that's right here. And now when I'm counting a, since it's under y, I'm going to be counting up and down. Okay, so from the center, I'm going to be counting up 6, 1, 2, 3, 4, 5, 6. And then I'm going to be counting down 6, 1, 2, 3, 4, 5, 6. Okay, so since this is the longer axes, this is now a vertex and a vertex. And now my major axis is going up and down, where before we were seeing it going left to right. So this is at -1, -4. this one is at negative 1, 8. And let's count the smaller axes that's in purple. So since, again, the 5 or the 25 is underneath the x, it means I need to count left and right from the center. So 1, 2, 3, 4, 5. There's 1 point. 1, 2, 3, 4, 5. There's my other point. Now let's label these. This is 4, 2. And this is negative 6, positive 2. Let me write this over here. And this is a co-vertex because it's on the smaller axes. So now let's connect these points. See, now this one kind of formed more of a circle. When I held it down, I don't know if it'll fix. No. Okay, so I'm just going to make an ugly ellipse right here. So let's label our major vertices are at negative 1, 8 and negative 1, negative 4. Our co-vertices on the smaller axis, so the shorter distance, is negative 6, 2 and 4, 2. And now let's find our foci. Still the same formula, even though A and B are switched. So I'm going to get 36 minus 25. So c squared is going to equal 9. So c equals plus or minus 3. So I'm going to be adding 3 from the center. Okay, but since my major axis is the one in pink going up and down is the y, right? So if I'm shifting up and down, I'm shifting along the y-axis. So what's going to be changing is going to be the y value rather than the x value in this case. So from the center, I need to count 1, 2, 3. There's one focal point, down 3 from the center. There's my second focal point. Okay, and now you could either just add 3 from the center to the y coordinate, or you could just label this point, since this one is a clear point, it's not being added by some radical number. I could see that this is at negative 1, 5. And the other one is located at negative 1, negative 1. Now, if you wanted to use it from the center, I know, so this is an alternative method, I know the center is at negative 1, 2, and I could add to the y value, because I'm shifting up and down, plus or minus 3. So 1 point, we would get negative 1, 2 plus 3, that would be 5, so we already found that point, and negative 1, 2 minus 3, that would be negative 1, and you could get your focal points that way as well. Okay, again, don't place too much emphasis on actually labeling the points of the foci. I would just want you to be able to at least graph them, and you should be able to identify which ones are your major vertices, so the ones that lie on the longer axis, and then your co-vertices, the ones that lie on the smaller axis. Okay, I hope this makes sense. Again, if this is confusing to you, please feel free to reach out, shoot me an email, and then we could talk about it.